Hi, I'm Elaine. Welcome to my podcast channel. Hi, Miss Lindenstrauss. How are you today?
Very well, thanks. How are you?
I'm great. I heard that you are a research mathematician at Indiana University. Could you please self-introduce about your specialties and field of study? Yeah, what you normally do?
Okay, so I'm an algebraic topologist, and algebraic topologists live on the seam between algebra and topology. Topology is the study of shape where you're not so interested in measuring, like in geometry, but you're trying to describe things qualitatively, like the figure eight has two holes. And if I did something with three loops, it would have three holes and they're different. So we're trying to discuss things like that, but sometimes it's simple, like if you have a flower with so many leaves, you can count the leaves. But sometimes it's harder to explain why you look at things and they really look qualitatively different. So we come up with algebraic invariants that are groups or rings, and they capture these these topological qualities of spaces. On the other hand, sometimes we also take algebraic objects and associate to them topological spaces where some property of the group or ring is captured, and sometimes it's easier to manipulate there, and sometimes we zigzag back and forth. So it's a sort of opportunistic field, but I find it very beautiful.
Yeah.
And one of the applications that my work is most connected to is some invariant in algebra called algebraic K-theory, which is quite connected to different things, can be defined in different ways, and they give you the same thing, but it's really hard to calculate. And there's some methods in topology that help you calculate it. So basically, and the seam between algebra and more visual stuff.
Yeah, that sounds really interesting, actually. So as a professor at Indiana University, what is your daily schedule normally like?
Oh, it depends. Right now I'm on sabbatical. So
Oh,
actually, I'm in the Institute of Advanced Study and just doing research and listening to talks.
mhm.
But when I'm at home, well, the administration thinks of the job as sort of 50% research, 50% teaching. So, um, yeah, so I teach every semester one or two classes, and then I have office hours, and I have graduate students, and I prepare and I do research, and I communicate with my co-authors
Mhm.
and do administrative stuff. And it's really like every day is different, except of course you have every semester you have your standard weekly schedule of when
Mhm.
your courses
Yeah.
are.
Yeah. So, are you normally really busy, or you think that your current schedule is um, moderately relaxing, moderately hectic? So, is it really busy or not really busy?
Well, I mean, during the semester when I'm not on sabbatical, it's
Mhm.
pretty busy.
Mhm. Yeah. Uh, I noticed that a lot of high school students are struggling with math. They normally, do you think that mathematical struggles normally come from how you're not interested at the first place, or it's just how you don't practice enough problems? How do you think high school students could best prevent this problem?
I mean, it's a big question, and a question that a lot of people are really trying to figure out, because we want the citizens of tomorrow to be numerate, not to be scared of this aspect of dealing with things. Um, I think, well, I think there's a lot of fear,
Mhm.
and I think somehow people think that math is some kind of, well, first of all, some people think that you either know it and you don't need to be taught, or you will never learn it. And that's completely silly. It's
Yeah.
just not true. And um, and some people think it's like some kind of test that is going to test them, and
Mhm.
measure them. And again, that's really a very unfortunate way of thinking about it, because the good attitude is that math is something you can understand, and it will help you understand various things you're interested in. And if you have the right attitude and there's the next bit of math and you don't understand it, well, then you have a well-defined problem, and you can ask your teacher, or go to office hours, or talk with your friends, or look at videos on YouTube, or whatever it takes
Mhm.
to figure it out. But when you have a problem with something in math, one should think about it as, oh no, here's this thing and I don't understand it. I would like to do something so I do understand it, rather than, oh, okay, here's a proof. Here's a math thing I don't understand. It shows that I'm not a math person. It shows math is not for me. It shows I can't do it. I need to go away. I, I don't know how to teach this attitude to
Mhm.
people.
Mhm.
I mean, I guess maybe getting confidence in elementary school, where you feel, okay, there's this competence. I just learned to add numbers. Oh, good. Now I learned to subtract numbers. Oh, good. And understanding each step probably would give kids more mathematical. But I mean, there's a lot of people whose job it is to do research into this, and it's a really hard problem, because I mean, each person thinks it's just them, that all those other people, they could be fine at math, but me personally, we've just proved that I can't do that.
Yeah. So attitude is really, really important for math, you think? Yeah,
Yeah.
definitely.
And
And also, I found that I don't know about the US, but in Canada, there are lots of math faculties, especially elementary math teachers or high school math teachers. They don't specialize in math and they're teaching math. So, do you think that might be the problem why math isn't really taken seriously at the beginning stage of learning? So, that is why a lot of people don't really pay that much attention to it.
I don't know. Um, I think there's a lot of fear that students get from the environment about math. So if their experiences, for some kids, are not really positive from the beginning, I don't think you need to, like, if you want to teach in elementary school, the kind of math that's taught in elementary school, I don't think you need very technical knowledge,
Mhm,
but you do need a positive attitude. Like, you need to give kids the sense that what you're teaching them makes sense, that they could do it several different ways and get the same answer, and that this is like 2 + 2 is 4. It's not open to negotiation. It's
mhm.
the way it is. We can see it in all these different. Um, yeah, I think if we could get rid of fear, we.
So mhm. I think a lot of people are actually scared of math, especially some of my high school classmates. They kind of dislike or repel this math, like they're no, it's not for them. And yeah, I think maybe somewhat inspiring them with how math connects to the society kind of works too.
Yeah,
Yeah.
yeah,
Right. So totally, I agree with your point. So if you want to learn anything or math in particular, in this case, you have to face it, and then you can't be scared of math. You have to just solve the problem. Another question is, what do you think about Googling math problems? So if you're stuck on a problem, do you recommend students to Google the problems, or you think that they should spend um, as much time as possible on that problem and then solve it?
well, as much time as possible is not. I mean, I do believe that, again, another bad attitude, which I remember discovering in high school at some point, that
Mhm,
sometimes I got a problem and I didn't know how to do it. And if I sat there for a while, I was able to do it. It surprised me, because before that, I just thought, okay, this one I know, this one I don't know. That was not the correct attitude. So I do think it's worth spending some time with a problem. And I love it also when students in my classes have study groups where they
mhm,
talk to each other. And a good study group, a really good study group, is sometimes a place where sometimes you get things explained to you, and sometimes you explain to others, because you also learn a whole lot by explaining things to your peers.
Yeah.
So my ideal student would spend some reasonable amount of the problem, then talk about it with their study group. If that doesn't work, talk about it with me. I don't really, that's what I tell them to do. I don't really mind if they manage to find somebody who explains to them how to do a problem on the internet or anywhere else. But what I would like is that, okay, they're totally stuck on problem number one. So they go to the internet and they find some explanation, and they formulate to themselves what it is they learned. And then they go do problems 2 and 3 by themselves using this new skill that they got. So, I mean, regarding it, it's a tool, and I don't think it's not a legitimate tool, but you shouldn't just regard doing homework as some kind of searching procedure. It's a tool that you can use to help you independently analyze what's going on with your problem. So,
Yeah. Yeah, interesting. So I actually found you on in the website of Indiana University, and I did some research, and I found that it's your son Daniel Larson, just to
oh,
make sure everything is correctly researched. So how did you inspire him to be so mathematically ingenious?
well, I mean, I guess it came from him, but when the kids were little, we played, like, in the beginning, what was it called? This candy lane. This thing that you get some, you roll a die and then you get to go some number of steps. So you count. So when kids are little, I think it's good for them to play counting games.
Mhm.
And then you can move up to Chutes and Ladders.
Yeah.
Candyland, yeah. And then you can move up to Chutes and Ladders, and then you can move up to Monopoly, and all these games that just they don't teach you anything very deep, but they get you used to adding and subtracting. The first counting, and then adding and subtracting, and then, like Monopoly, you can give change and all that kind of stuff. Um, just giving people a comfortable sense of competence with basic mathematical operations is very useful. And then as he became older, my husband was running a math club. But I was again talking to kids about concrete problems and trying to make them understand simple things. And then I guess there's two things. First of all, it's good for a kid to be curious, so it's good to answer their questions.
Mhm.
Um, and curiosity is, of course, good for all things you might want to do. And secondly, just um, give people mathematical competencies and have them be comfortable about that. And then they know that if there's the next thing, well, they could become competent at that as well.
Yeah.
And
Yeah, for sure. And so I think giving them some confidence and then, oh, you can do it, you can still try your best and you're doing great. Especially it's a way of inspiring mathematically empowered people too. I think that's really good. And also math games too. I think they also help to inspire lots of mathematical thinking too. Yeah. So I've also done some research and he came up with a proof at last, which is amazing.
yeah,
So did you work, did you also support him a lot through his way of coming up with a proof?
well, I mean, he would explain things. He wanted to talk about them. Most of it was above my. I mean, it's things I'm not part of my expertise, but I
Mhm.
tried to be a a, a person willing to discuss it. And I mean, we were amazed at his persistence. Um,
Mhm.
he was also lucky, but he also worked very hard.
Yeah.
And yeah, we're very proud of him. But it was really something that came from within him.
Yeah. So back to the high school students thing. How many hours do you think each student, like anyone who's doing math, including me, how many hours do you think we should spend on math on average per day?
Oh, I don't know. It depends. So say you're taking one math course.
Yeah.
Okay. So say you're taking, but it also depends. I mean, some people sometimes overreach and that requires more hours. But
Mhm.
but maybe if you have a course, I don't know, like a university course, I hope my students spend 7 or 8 hours every week on work related to my course.
Mhm. Yeah.
And it's of course good to do it early so that if you get stuck, you can talk to your friends and you can come to my office hours.
Maybe gonna come and visit you at Indiana University and we can talk about math. But yeah, so maybe around it really depends on different people. I think for high school students, maybe 2 to 3 hours, if that really is a number
Oh,
that's
per week or per day?
per day, if that
Oh, wow.
works.
Well, if you could do that, that's wonderful. I mean, it really depends on what your course is and how much homework you're getting and how quickly they're going. It's a very relevant issue.
Yeah.
And whether it's an overreach, whether you were super prepared or you're missing a bit of the prerequisites. You'll have to work more if you have to catch up a little bit.
That's true. I really like your idea, how you have to. Really depends on different people. How you sometimes you have to catch up, or sometimes you're just like pretty lucid, and it's also connected to your personal choices and attitudes as well. So it really
Yeah,
depends on different people.
yeah.
So based on your university math courses teaching, which course did you think was the hardest to teach, and a concept that was really hard for students to grasp?
Well, I mean, I teach a lot of honors introductory calculus courses, and uh, there a big thing is formalizing the idea of limits.
Hmm.
And people think it's at first students think that I'm just making their life hard. That, of course, as x gets closer to 3, then what would x squared do? It has to get closer to 9.
Yeah.
So why am I making them do this in this complicated way with two quantifiers and um, whatever? But the reason is that some things are very clear, like what is x squared going to do when x gets close to 3? Of course, it will go to 9.
Hmm.
But what is sine x over x going to do when x goes to 0? So sine x gets really, really small, and x gets really, really small. And who gets small faster? Well, a priori, you can't just do it by logic. So you have to do something formal. And of course, because I'm trying to teach this technique, this is like epsilon delta approach to limits. So
Hmm.
because I'm trying to teach it, I use at the beginning simple examples, and because the examples are simple, the students think they could do them without my method. But but eventually they understand that we need this method because there are some examples where you can't just know it by staring at it, and then you have to work with it. Of course, there are other things that are
Hmm.
hard to explain, but that's a big obstacle in the beginning of the funny thing is that once you accept this idea of doing limits properly, then
Hmm.
it becomes very easy to work with because you describe all the properties, and the properties are very intuitive, and you just prove that they're valid. But then you have the properties, and then you can work with it quite quickly. But in these courses, it's sort of a front-loaded thing that you have to understand this concept, and you think you sort of do, but the definition is formal, and the formal definition is not so easy. And I guess proofs in general.
Yeah.
One of my favorite classes to teach is Introduction to Abstract Algebra,
Hmm.
because you get a lot of people who in the beginning aren't experienced with proofs, and they don't understand what's this proof thing that we keep talking about. And it's like light bulbs going on during the semester at various points. different people suddenly get it, and then they become very happy, and they like me, and they like the course, and they like everything. And then they have this tool, and then it's wonderful for them for other math classes.
Yeah.
But it's a struggle until you get it.
Yeah, for sure. Like at first, if you just get into university, like you were a high school student and the next day you're a college student, and it must be really, really hard to write proofs in this mathematical language. How can I write a good proof? It's sort of different, and I guess that you have to struggle for a year or whatever until you can actually
until the bulb goes on. But it's important to know that it's hard for everybody until you just get it. And so, yeah, people get pretty unhappy, but you just want to keep going because by the end of the semester, most of them do get it.
Yeah.
And then it's really nice. Of course, some come knowing it. And for some people, it's easier than for other people. But that just means that, okay, or maybe they're lucky, or maybe they've seen more similar things. But most people, if they really persevere and try to understand, assume that it makes sense, and just ask and ask and ask until they figure out how it makes sense, they will get it. And that is a wonderful thing.
So asking questions too, like why is
questions? Yeah. Not being embarrassed about not understanding. Like if you've done the work and you don't understand something, then you're entitled to ask it, even in class, and you shouldn't be embarrassed about not knowing it. And probably if you have a question, there are a lot of other people who also don't know the answer.
Yeah, just say it in class so you can ask it for us. So yeah, I totally agree. Even math classes offered at my school, I think that a lot of people or students are struggling to speak up even because they are really scared if I ask this question, would everyone think I'm stupid or idiotic? But I think really it's just ask the question and discuss that topic. It doesn't really matter, but yeah. And related to what you were talking about, confidence actually
Yes.
has to do with this math too. So be confident, just take risks as well. Yeah.
Yeah, just the idea that if you've been doing the work, if you've been showing up and you've been reading what you're supposed to read and you've been trying to keep up and you don't get something, you are entitled. Confidence is hard. It's better to be confident. It's important to be confident, but it's hard to tell people, now you go be confident. But to tell people that if you've done all the work and you don't get it, you're entitled to ask. That's maybe easier to explain because you wonder, am I allowed to do it? Am I not allowed to do it? So yes, you are allowed to do it.
Yeah, for sure. And do you think that mathematical competency, like basically how one is really good at math, do you think it's associated with this intellectual competency, or maybe someone has high IQ and maybe that person's smart, so that's why
I hate that. I hate this idea of math as a measure of IQ and IQ as a measure of intelligence. I think that's related to a lot of the bad attitudes. I wish we didn't think that way. I mean, different people are smart in different ways, and if they try harder at different things, they will do better at those things. And it comes more easily to some, for sure. But if motivation and perseverance help too, and yeah, I mean, that's, I think, maybe the thing that scares the kids who think they're not good at math. They just think they don't know the answer to some question, and they think that the question measures how intelligent they are, and they're not intelligent, and therefore they avoid these questions in the future, and some kind of horrible positive feedback loop in the bad direction.
Oh, for sure.
So we really don't want to think those. I mean, it's true that a lot of tests that people use have math questions, but somehow, but no, there are very intelligent people who find math difficult, and we all know them. And we really shouldn't measure people by how good they are at math.
Yeah,
that's a silly idea.
Yeah, I guess because a lot of people maybe find math hard, but really, as a human, there's so much parts to the brain. Maybe someone's really artistic and another person's not artistic at all, but very logically competent, or is really, really good at math, but not good at painting, something like that.
Yeah. And I've met people who are very good with logic and complicated deductions and are scared of numbers. If you put it in numbers,
Yeah, for sure. And since you are teaching, I would say algebraic geometry or something, is
algebraic
it
topology, yeah.
topology? And
But
topology, I think, is the hardest. I don't know. A lot of people say that topology is actually the hardest course they ever encountered, and a lot of tears come out when they study topology.
oh,
Do you think that is true? It's a really hard course.
oh, well, I don't. So we teach it as a first year graduate course,
Hmm.
and I don't think it's the scariest first year graduate sequence at all.
Yeah.
I hope not. I hope they don't cry. I mean,
Yeah, I guess a lot of different courses. I mean, different courses are hard for different people.
oh,
Um,
but maybe, but algebraic geometry maybe is a little scarier than
yeah.
algebraic topology. So I teach algebraic topology, which is less scary than algebraic geometry. At least I think so.
Oh, what makes it less scary than algebraic geometry?
Well, I'm smiling as I'm saying it. I mean, I guess the reason is that I know algebraic topology and I don't know algebraic geometry. But
Okay.
that's okay. But that's a good point. That if I know something, it's not scary. If I don't know it, it is scary. So you know, so if I try, and I need to sometimes use algebraic geometry, and the correct thing is to isolate what I need and look it up. And I definitely use the internet. And I now we get all the papers on the internet. So there's there's a sort of place where you can see all the papers and you try to search for something relevant. But the correct thing when I need something from that area, which I don't know, is to isolate exactly what I need and then try to regard that as my problem and try to find some resources to help me to solve it, rather than to say, oh no, this is not something I know already, so I can't, I'm stuck. I have to go away. This is not going to work. I mean,
Yeah, for sure. Of course, math is like such a large tree with different branches and then topics. It's like a
yeah.
broad idea. Like, I think that um, you just can't know all the math ever.
Oh yes, yes. I mean, that's really. I mean, math has become so much broader. It's huge. Nobody knows all of it. Nobody even knows most of it. Yeah. It,
Yeah. And if you like specialize in math and you do math for all your life, you might just know, I think, 1% of all the math ever that exists. Is that true?
maybe. I probably that's. But there's people who are broader and people who are narrower.
Mhm.
And also, it depends on what you consider math and what you don't consider math. So it's hard to give an exact number, but it's gotten so. I mean, it's a wonderful thing, really. That math has become so broad, and there's so many things that are being studied, and there's so many connections to the real world that are being made. That yeah, I mean, you could regard it as scary that you can never know all of it, or you can regard it as very reassuring that you'll never run out of interesting things to learn.
Yeah. Lots of things to learn. And do you think it's important for high school students to, if they for targeted to people who really enjoy mathematics, do you think that they should choose a field, like narrow it down and just look at, for example, algebraic topology just for their whole life and then just stare at that problem and make sure they're super good?
No. In high school, you should learn everything that's being offered. As an
Mhm.
undergraduate, you should try to be as broad as possible.
Mhm.
As a first year graduate student, I even encourage people to keep an open mind and
Oh,
try.
yeah.
I mean, it's nice when the students choose a graduate school. It's nice when they have some idea of a direction they might go, which would help them choose a school that at least has something in that area. But really, like my first year advisees, I encourage them to um, keep their mind a little open, see what's around in in our university,
Mhm.
um, and then okay, at some point you have to write a thesis, so you have to specialize and figure out, but not until the first year of graduate school. As an undergrad, you should try to learn as much as possible. As a high schooler, you should try to learn as much as possible.
Mhm. Wow, I'm really surprised even for undergrad because, um, I thought at first I thought maybe for undergrad or the last year of high school, you should stick to a problem and then figure it out for your whole life. But that's probably not true. You have to, of course, as you mentioned, broaden your perspective. Your choices might change in your future study.
Exactly. Yeah.
Yeah, because maybe like I've heard that even people who uh, first year as a history major, they switch to like a totally math major. So like they might just change maybe.
Oh, we have a lot of them. Yeah.
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 So what are normally your teaching methods in at university? Do you normally handwrite the math formulas or you prepare a PowerPoint to showcase your lectures or
No,
both?
I like traditional board
Yeah.
lectures. I think I understand things better that way. So for one thing, if you're teaching, if you're writing things yourself, you're doing it at human speed, and then the students can absorb it in human speed. And the more you say it and write it, they can see this is the thing that you think is important. And, you know, I really want to get things as much through the human um, channel as
Mhm,
possible. And I
mhm.
think Blackboard lectures are, I mean, I've taught other ways when I had to. And certainly in math conferences, there's this kind of conference we have where you get 20-minute talks. So 20-minute talks I do with transparencies
Yep.
because they're sort of fast. But if it's possible, I really like the human speed, the human the presentation through the human.
Yep. So more like I would say that your method is more humanly connected, human connection, and
Yeah.
less like because we have AI right now, everything's technological, but I think you prefer this one-on-one human to human
Oh,
connection.
one-on-one is wonderful. But even if I have a class, I
Yeah.
really prefer writing myself on a blackboard.
Hmm. Yeah.
And when I hear lectures, I really prefer it when the person writes on the blackboard.
Yeah. Yeah. Especially if you have just a bombardment of information presented on a PowerPoint, it's like, oh, what is this about? And then it's
Exactly,
really hard
exactly,
to follow. Yeah, for
exactly.
sure. And how many students do you have per class?
Oh, it really depends. So in the graduate classes, um, sometimes it's less than 10.
Hmm.
Um, undergraduate classes, but again, I mean, I don't know. There was one class I taught once, and it was I had 40 something, and then next time I taught it was like 15. It really varies.
Hmm.
Um, um, you can't. I mean, to run a class, if it's graduate, we need at least 5, and if it's undergraduate, we need at least 10.
Yeah.
But but like when we teach regular first year science, calculus, then it's like 60ish or 70ish.
Hmm. So
Yeah.
it's a really large classroom. So compared to large classes and small classes, which environment do you prefer and which one's more easier to teach, do you think?
Oh, I think small classes are easier and better. It's just cost
Hmm.
money for the university. But I mean, I think students really benefit from having the instructor look at them and try to see if they understand or not. And they say, oh, well, okay, I'm being looked at. I guess I should figure out whether I'm understanding. I mean, they feel much more committed um, to participating in lecturing in the class if they, you know,
Hmm.
people see what they're doing and expect them to understand and are there to help them if they don't understand. So
Yeah, for sure. And I think that in a smaller room, it's sort of like more engaging. Like I'm not the one who mixes up with 70 or 100 other people. And
yeah.
yeah, I think so in your 70, like you as you mentioned, in a 70 people class, do you think there are students who raise their hands to speak up, or are there much engagement in your large classes?
Well, in 70, yeah, there are people who raise their hands. It's often the same ones, but one tries to. I don't like, when I was a student, I wouldn't like having people call on me randomly.
Yeah,
So
yeah.
I don't call on people randomly, but I love it when people, different people participate. But even if it's always the same ones, if it's somebody who's willing to show that they don't understand something, usually there's many other people who don't understand it, and they appreciate that.
They appreciate that person who asks their questions.
Yeah, yeah, they do. And I appreciate it. It also slows me down. It makes things more.
Mhm.
It shows me where people want more support. So
Yeah, for sure. I think that really makes sense. So because our the whole math field is like so broad, do you think any math fields will stop developing through time?
all the fields have ebbs and flows, and that's the way it goes. I mean, there are periods where there's some, like, if somebody made a breakthrough, then everybody wants to see what the breakthrough would imply to their problems. If somebody
Mhm.
made a connection to another field, then suddenly there's all this excitement about you know, whether there's applications that will be useful. There's also just fashions sometimes.
Yeah, for sure. I've heard that PDE is very fashionable nowadays. A lot of people work on that, and also number
Oh,
theory.
yeah. Oh, number theory is sort of, well, but both of them are sort of eternal, because
Yeah.
PDE. Right, what are the big inspirations for mathematics? I mean, the world around us, physics and stuff, and that involves various differential equations
Mhm.
and the properties of the natural numbers. So these are the two big things that led to developments of things. So I think they'll always be in fashion.
Yeah. So, in pure math, we have a lot of conjectures too. Do you think that pure math are most like in science, we have hypotheses and then we have plenty of debates, and in pure math, do you think a lot of concepts are debatable or they are for sure this theorem or do you think, yeah.
Oh no, that's the beautiful thing about mathematics. I mean, if you prove a theorem and you didn't make a mistake, then you have proved that theorem.
Hmm. So it's not debatable, like it is what it is.
I mean, sometimes people write these very long proofs that are very complicated, and people wait till some experts read it and figure out if it works or doesn't work. Because if there's a small mistake in the middle, maybe the whole thing doesn't work.
Mhm.
But once the proof has been accepted, once several people have understood how it works, then it tends to be. I mean, okay, sometimes it's sneaky. Sometimes there's sneaky mistakes, but basically,
Yeah.
often also when somebody proves something, then people know it's true, and then maybe it's easier for people psychologically maybe to find other proofs. So if you could prove something by two different ways,
Mhm.
and more confidence that it's true. But the question of whether something is true, I mean, okay, if somebody finds a mistake, then that's a pity, and the thing is not the proof false. But it's not so much of an argument. Like, the fashion now is to accept this theorem. Now the fashion is not to accept this theorem. There isn't
Mhm.
any of that. That's one of the nice things about mathematics.
Mhm.
It also gives you self-confidence. Like that's
Yeah.
the wonderful thing about proofs. If I can prove that such and such is true, then unless somebody tells me that I made a mistake on line 7, then I know it's true, and I don't care what other people say. I have confidence that it's true.
Yeah. For sure. And do you also, when writing a math proof, do you recommend um, showing it to your friends or you
Showing it
prefer,
to peers, absolutely, it's very good to show it to peers.
because
Yes.
some people might think, oh, my math idea will be leaked to other people or whatever.
Oh well, okay. If you have super hot things, but it's good to have like people you trust
Mhm.
who are close to you at
Yeah.
the level where you are, that you can show them, run things by them.
Yeah.
Yeah.
So another question about regarding math clarity, especially writing a math paper. how do you think one should make their math proof as clear as possible, like formatting or the structure in math language?
Oh, formatting is not too dense. I mean, basically, I think more people err on the side of omitting details. Well, with my students, I tell them that when they write homework, they can
Mhm,
say that things are obvious if I call them on it, then they will immediately start explaining to me why it's true without having to think. Now, it might take them 2 days, but they won't have to think. And if they have to think why it's true, and they won't be able to just start telling me why it's true, then they can't just say it's obvious. You should think very clearly. And once you think very clearly, then you're probably going to write it in an okay way. And there's still the question of what level, how many details you should fill in. But um, the correct answer there is you imagine who your audience is and try to figure out what level of detail. I mean, within good papers, there are papers that are more detailed and papers that are less detailed.
mhm. It's always better to add as much detail and description as possible because a lot of people think that, oh, this is so repetitive. And do
No,
you
it's
think?
not always. No, it's a fine balance. Um,
Mhm,
but but I prefer to err on the side of too much detail, and maybe some people don't like that, but that's my personal. But you can't write every detail. I mean, you have to have your audience in mind, and if there's things that are going to be obvious to your audience, then they don't need to be spelled out in detail. But you shouldn't use the fact that you don't want it to be too detailed as a shortcut to avoid thinking clearly about what exactly it is that you're trying to say.
mhm.
Because if you
Right.
don't think clearly before you write, it's not going to come out good.
Yeah. So regarding coming up a new math formula, do you think that you need a lot of tons of math expertise and knowledge in order to come up with your own formula, or do you think that a lot of high school students they can come up with their own formula and how they work like a math formula themselves, or do you think you need to be a postdoc or
No, I
someone
mean,
so
it
much?
depends. It depends what if you just want to say something and you don't care if it's interesting or not. That's not very difficult. Um, the question is, how do you say something interesting? And I think trying to understand something. If you really want to do research, it's nice to have guidance from somebody more experienced,
Hmm.
tell you what's obvious, where you can look for problems. It is true that the more you've seen, the more tricks you know, the more methods you know, the more ways to change the problem into something you can work with you have. So it's that's another reason for this breadth that I was recommending earlier.
Hmm.
Um, but I think coming up with something new per se is not so hard. The question is coming up with something new that's interesting. And
Hmm.
when you're young, I mean, that's why even with PhDs,
Hmm.
we have a thesis advisor, and often the thesis advisor either gives you a problem or gives you feedback as you select a problem. Is this doable? Is this interesting? Has this been done?
Hmm.
Finding something that's both doable and interesting is difficult. And so
Yeah.
high school students shouldn't feel um, inadequate if they can't do that themselves.
Yeah, because I think it takes even mathematicians a long time to find
Precisely.
a new
Yeah.
formula.
Yeah.
Hmm.
But
Yeah.
there are programs for high school students that connect them, for example, to graduate students
Hmm.
who can help them find such problems. And also, they shouldn't worry about doing research so much in high school. They could start with learning something.
Yeah, I think a lot of high school students are thinking to apply to research programs, or I have to work with a prof to apply to university even, so I can get in at least get into a big university. But I think from a lot of interviews from other professors, they also recommend just reading for fun, reading math books. I think
Yeah,
it
yeah,
works.
yeah, yeah.
Mhm.
Because when you're in high school, You want experience. You want to see what's there. You want to see how people deal with problems.
Hmm. Yeah. I think, are there any math books that you, in particular, you really enjoy that you recommend for high school students or undergrads or postdocs or anyone out there that you find really helpful?
Um, yeah, I mean, I think just a nice. So I really like for honors program. I really like things that have proofs. So I think just linear algebra with proofs. There are many books who do that, or calculus with proofs, like the beginning of an analysis. There's a book called Baby Rudin.
Yeah.
book. So reading a introductory text with proofs slowly about a subject like uh, elementary calculus or like linear algebra is a really nice place to start.
Mhm.
It doesn't assume much, and you really, and people are used to reading like lots of books for their humanities courses, and they think,
Yeah.
okay, I'm going to read a book a week or whatever. No, you
Yeah.
won't, and that's okay. If you learn something, if you spend time and you learn something, then that's great. And if you take a semester and you read a chapter in a book and you understand it, that's great.
Mhm. Yeah, I think even, do you prefer reading like 5 or 6 math books at a time, or do you think that nowadays students should read math books 1 at a time instead of having 5 or 6 books at a time and they read it together?
Well, sometimes there's subjects that are treated by a couple of books and they're different in their approaches, and you can understand a bit from the one book and then bring it to the other book and go back and forth. So certainly there are situations where I was trying to read something, so understand something, and had several papers and go back and forth between them, and that helped. Reading whole math books is a big job. People don't do it so much, but well, when you're more advanced, like when you're taking a class, then often there's the main textbook and some supplementary books. And sometimes I when I teach a class, I teach from the book that I think is best, but I give the students a bunch of other books which different people learn differently. That's another important thing about math. Different people learn differently, and maybe the other books work better for them. And sometimes people were really excited about books that I just stuck on the list because I thought, why not?
Yeah,
Um,
for sure.
whatever works, but if you're not taking a course, often people are motivated by what interests them, and they find it some later stage in a book, and then maybe they need to read up to that point in order to understand that, but maybe they won't read the rest of it. Or some people are very disciplined and they can read books, and I admire that. I'm more the kind of person who finds what I need and then I try to read the earlier stuff so I understand how they did that, and then
Mhm.
what I wanted.
Yeah, for sure. And sometimes if you just hold on to 5 or 6 books, it might slow you down, or especially for some people, they just, oh, this. What I found super funny from my interviews is that a lot of mathematicians, they buy hundreds and thousands of books,
Oh
like
yeah.
classical, like the premium edition of math, and then it's the last copy on their shelf, and then it's like a whole book math shelf, and then, oh, I asked, oh, so did you read all of them? And then they said, no, I didn't. I just buy them to keep them there. So
Well, no, but it's good to have the books there so that when I mean, you have to, I don't buy specialist books in different fields, but I buy books in my area, even if I don't intend to read them immediately, because, you know, they might have something I want at some other stage. And I sometimes look at, if I have energy and I don't have pressing projects, I look at my books and I sort of find some interesting things, and I read some local bit. I mean, just reading a whole math book is a major project, and it's sometimes it's what you want to do, but often it isn't. And
Mm.
and I totally understand having more. Yeah, I've interacted in some way with each of my books, but I haven't read them all.
Yeah, it's especially math, like it's really hard to read yourself. I think, do you think that you need maybe a friend or a teacher there so you guys can read it together, and figure things out?
That helps, but you could do it yourself if you are not committed to going through it at some rate that somebody invented. So if you're reading this at the speed it takes you, and then when you understand something new, you pat yourself on the back. You have achieved something.
Mhm.
If you go with this attitude, you can also do it yourself. It's better with a friend, it's better with a teacher for sure, but you can do it yourself as long as you don't give yourself crazy standards about going really quickly and the book is at a suitable level.
Yeah, yeah, for sure. Um, to end off, do you have like a major last recommendation for high school students or whatever, whoever who's super interested in math? Like any last recommendations?
um, yeah, don't worry about speed. The name of the game is understanding how things work, why things work. Try when you're being taught various techniques in algebra and calculus, whatever you're taking, try to understand why they work. That's the core of the thing.
Yeah. Thank you so much for answering my questions.